However, following this dimming event, the star's behavior has undergone a transformation. Previously, it would pulsate or adjust its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variations in its length and temperature. This red giant star is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be due to pulsations in the fundamental mode. The second period is a longer cycle of about 5.6 years, and its origin remains unknown. In their research paper, scientists provided computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, similar to a large and intense bubble, emerged from within the star. These occurrences of hot gas bubbles sometimes arise out of the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is continuously in motion and mixing. As this hot bubble ascended and broke through the star's surface, it caused the ejection of stellar material. Apparently, it also disrupted the star's normal pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its normal 400-day pulsation to a new 200-day pulsation. Astronomers expect that the star's normal motions will gradually stabilize the unusual pulsation over the next 5 to 10 years, eventually restoring Betelgeuse to its regular 400-day pulsation. Concerning the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time in the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening now would only become visible to us after 650 years, due to the limitations imposed by the speed of light. Therefore, it's highly unlikely that we will witness the star's dramatic death during our lifetime. The unique thing about Betelgeuse is that we can see its surface, which is not the case for most other stars. This offers us an outstanding opportunity to discover how big stars like Betelgeuse behave as they age. Alongside these surprising mass ejection activities, astronomers made a bone-chilling discovery. For the first time ever, they found a star devouring its planet 12,000 light-years away, in the constellation AA. Betelgeuse, with its intriguing name and prominent position in the midnight sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology worldwide. Betelgeuse has a rich and diverse origin, rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often related to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the wet one. To Hindu astrology, Ardra lunar residence is associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse played a significant role in cultural practices and traditions. For example, in Macedonian culture, it symbolized domesticated animals and agricultural life in villages. In different regions, such as North Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence stems from its association with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it captivates and inspires artists, writers, and filmmakers. In recent years, Betelgeuse has undergone remarkable changes, catching the attention of astronomers worldwide. From massive dimming events to a large surface mass ejection, SME, Betelgeuse has exhibited behaviors that offer unique opportunities to study the dynamics of dying stars. The 2019 dimming event, followed by the SME in 2020, allowed researchers to directly observe and analyze phenomena that were previously theoretical or inferred from remote observations. The SME, particularly, was a pivotal event. It ejected a mass far more significant than typical activities observed on other stars, giving astronomers valuable insights into the mechanisms governing such eruptions. This event not only provided a real-time glimpse into the star's internal processes but also challenged existing models of stellar evolution and mass loss mechanisms. Furthermore, Betelgeuse's unusual pulsation pattern, shifting from a 400-day to a 200-day cycle post-SME, has intrigued scientists. This change suggests ongoing dynamic processes within the star, possibly related. Prestigious new role, now shining brightly because the seventh celebrity in our inspiring midnight sky, Betelgeuse, a huge superstar in its overdue stage of life, is of extensive length. Its dimensions are so good-sized that if it were located in the center of our solar system, it would expand as far as Jupiter's orbit. In the end, this well-known star will undergo a collapse resulting in a powerful supernova explosion, which might also result in the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova stems from the reality that it may be an event placed approximately 650 million light-years away. Humanity finds itself in an essential region to witness this cosmic spectacle firsthand. When the stellar explosion takes place, it will produce a wide-ranging display of light. Initially, there will be an abrupt influx of neutrinos that will sweep throughout the Earth, detectable via observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar particles, Betelgeuse will swiftly intensify in brightness over the course of a week, reaching up to 10,000 times its traditional luminosity. Depending on the explosion strength, this celestial beacon could rival the brilliance of a full moon and might also be seen during daylight hours, casting fantastic shadows at night. This incredible event will persist for an extended period, presenting an outstanding opportunity for observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may moreover trigger speculation and apprehension due to historical associations of such events with ill omens, we can take solace in the fact that we are appropriately located at a large distance, protected from any damaging consequences. To fully recognize the enigma surrounding Betelgeuse, it's vital to revisit the end of 2019, when odd phenomena started to occur. During this period, the red giant star commenced experiencing tremendous dimming, a change considerable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum indicated that Betelgeuse appeared roughly symmetrical, but its photospheric layers exhibited signs of enormous disturbance within our line of sight. The photosphere represents the outer layer of the star, where light is emitted. Researchers also detected an enlargement of the photosphere, giving the impression that the star was swelling when considered from Earth. This enlargement persisted at a steady rate of approximately 8 kilometers per second for most of the year until mid-November 2019, at which point the outward velocity commenced to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical snapshots of the star. Their observations determined sudden irregularities. Firstly, a darkened location appeared in the star's southern hemisphere, creating a contrast with the previous photo taken at the beginning of the year. Secondly, the surface temperature of the star experienced a dip, dropping by about 80 Kelvin between January 27 and February 13, 2020. The brightness of Betelgeuse reached an unprecedented low approximately a year after the cessation of the outflow, but the star steadily regained its brightness over the subsequent months, eventually returning to its normal value. This prompted the question, what had truly happened with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone a large and extraordinary event called a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand SME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upwards and outwards, causing shock waves within its environment. Over time, this material forms molecules and dust, partially obstructing our view of the star and causing it to appear dimmer. In the case of Betelgeuse, The SME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amount equaled multiple times the mass of the Moon, propelled at incredible speeds. Researchers stated that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for the direct observation and examination of surface details using the Hubble telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SME had a profound effect on Betelgeuse, causing it to lose a significant quantity of mass in a single event. This incident confirmed that a dying star can experience significant mass loss beyond its normal annual decline due to stellar wind. In a way, it was as if Betelgeuse had forcefully expelled its upper layer and was presently in the process of slowly recuperating from the aftermath of this damage.